So good morning and good afternoon and good evening, everyone. Welcome to another hackathon workshop. Today we have Vijay, who's going to talk us not through the enterprise roadmap to ETH2, as discussed, but actually enterprise Ethereum after the merge. And just a little bit of housekeeping, sorry. On the right, if you can see, you have the chat available at all times. Feel free to post any questions or any comments you want in there. Vijay can review anything. At the bottom, if you look, you have ask a question. And if you have a specific question that you would like to have answered, feel free to post it there. We will do a review of questions in the middle and the end. You're welcome to review the questions, to ask your questions there. And also if you want to vote for questions that have been asked and promote them as well. My name is Tamar. I will be assisting Vijay in hosting this workshop, and any issues that may come, I will try and facilitate them to the best of my abilities. And I think that's pretty much it. Let's get started. Vijay, floor is all yours.
Awesome. Thank you very much, Tamar. So hi, everyone. So this is an Enterprise Ethereum after the merge roadmap instead of to ETH2. As some of you who've been paying attention on social media will be aware, the narrative has been kind of forked, and we are now talking about the merge as we approach the kind of combination between the ETH1 execution engine and the beacon chain. And so, you know, this is actually quite a useful terminology because we are also approaching a kind of second, less concrete merge on the kind of enterprise side as we think about sort of creating the or sort of tapping into a lot of the stuff that's happening on mainnet for enterprises and sort of given where they currently are now. So hoping to walk you through that. I'm a product manager on the protocols team, and hopefully Julien will join me as well to present some of the stuff on Rollups on the also in this presentation. So what to expect in this presentation, where we are today with Enterprise Ethereum, for those of you that aren't familiar, and hopefully a little bit of a refresher for people who are already involved in sort of that side of the space. And then just kind of bridging the conversation where we are with Enterprise Ethereum into where we are in terms of R&D, different sort of product development, and kind of feature availability. And then finally, sort of painting a picture of what that looks like at the protocol layer, given all these new capabilities. So where we are today with Enterprise Ethereum. So I'm sure many of you have seen this, and this kind of just hopefully calls back to some people's earlier experiences with ConsenSys and earlier presentations you've seen. But this is just a graphic, an illustration of ARPANET from its first 4 nodes over the first kind of 7 years of its existence, kind of connecting, as you can see, a few different kind of local area networks into deep connectivity over a really short space of time. And you know, we use this metaphor because you can observe a very similar model if you look at the kind of business enterprise use of networks moving from corporate intranets to massively global internet services. And I think this is kind of a tenet that the Ethereum community has always kind of believed in, this global vision, that this kind of global level connectivity of digital services, especially using Ethereum, is unavoidable. And it takes a bit of time, but we will eventually get there. So, I mean, we can look back at the years from Ethereum's launch to the present and see that we've obviously made a lot of great progress in a bunch of different dimensions. But definitely during that time, there have been a lot of collective challenges for our ecosystem. You know, hard research questions to build out, and also, you know, just the kind of hard work to build all this software, which has enabled lots of different types of applications to be built and lots of different companies to be connected to Ethereum. And on the enterprise side, obviously, exploration with Ethereum started very early. And if you look back at some of the earliest enterprise blockchain proof of concepts, they actually used forked Ethereum before any of these other kind of options were live. And so we can talk a little bit around, you know, what it was like for these enterprises at the beginning of Ethereum. So, you know, there are lots of features that we take now for granted, capabilities around privacy, around sort of building robust private networks, and the kinds of integrations that enterprises expect that weren't in existence in Ethereum or in the Ethereum space. And similarly, we can talk about the kind of lack of that kind of enterprise grade vendor, the kinds of mature open source community custodians, etc., who we can see in lots of other kind of open source ecosystems. And similarly, there's a lot of kind of confusion and difficulty getting started on the enterprise side as well. So a lot of enterprises who were passionate enough to get started and stuck in didn't necessarily have the vision to sort of execute at the early stages, and certainly design patterns for decentralized networks weren't all there. So lots of the kind of earliest concepts you can see were very much sort of copying and pasting over antiquated architectures. And that's kind of before even getting stuck into all the challenges of corporate innovation, especially within big banks. And so we did see a lot of that actually end up funneling into some of these early consortia and other competitive DLT type solutions. And out of that kind of space as well, we got the EA. So the EA was some of Ethereum's first advocates in the enterprise space, being pragmatic and realizing that a lot of work had to be put in to bring Ethereum to where it checked the right boxes for enterprises. And there's good reason to be kind of careful like that. The history of technology is littered with lots of examples of best-in-class systems losing out. And so these kind of early corporate innovators, banks, ConsenSys, and others came together to sort of try and define some of these standards, some of these boxes that needed to be checked for enterprises to be comfortable using Ethereum. And so, and we can see a continuation of this kind of overarching theme, sort of moving towards mass connectivity in the specification. The extensions are kind of like part of this spec, but a very large majority of it is public Ethereum. And so, the goal here, the design goal, one of the design goals has always been the closer we stay to mainnet, the higher the kind of benefits of sort of tapping into all of the innovation that's happening on mainnet, and also the easier the kind of long-term convergences between these technologies. And as we can see at the bottom, there are kind of three primary themes that sort of fall out into the features and capabilities of Quorum as we've developed it. And so those are privacy, performance, and permissioning, which you'll occasionally hear the protocols PMs talk about as the 3 Ps of Enterprise Ethereum. All right. So as you'll all be hopefully very aware, Ethereum has come on a long way since then. And in particular, we've seen the tooling mature across the enterprise and the mainnet sides, across all of the kind of functional components you need to connect to networks, as well as just kind of general developer experience benefits like the great documentation that's available, as well as the kind of robust open source communities out there, people supporting, standardizing, and sort of coming together to add features, capabilities, and components to these existing projects. And that's alongside a lot of the R&D work that's been going on. So obviously the most exciting of which may be on the screen, depending on what angle you're approaching this from. But that's kind of in addition to many others. And this research has kind of unlocked new use cases as well. So, new kind of enterprise projects, which are maturing for sure. And, across digital assets and CBDCs, all kinds of tokenization. And as you can probably seen over the past couple of years in particular, the DeFi and the CeFi model kind of really coming into its own and sort of taking a global stage. And so this kind of drives, several different factors which I think are attracting enterprises in 2021 to think a lot more seriously about converging, what it might mean for them, and to kind of join this shared settlement layer and sort of tap into these network effects of all of this kind of financial infrastructure that's being built on the public mainnet. So just to kind of name a few at a very high level, so I won't run them all through in detail today, and I'll try and link you out to places you can learn more if you're inclined. But obviously sidechains are a thing. If if you've been keeping up to date with mainnet, you'll know that there are plenty of different kind of EVM sidechain networks which are being offered sort of as part of DeFi and other narratives. And then I guess here's my quick chance to plug doing a Quorum sidechain. It is almost perfectly built for doing that kind of use case. You have robust and efficient consensus. You have permissioning, so you can make it flexible for your governance structures, and you also have additional privacy options. And then everything else is Ethereum as you know it. Aside from a bunch of great logging, monitoring, and sort of customer support features that are all kind of enterprise grade. So we're already working with some people to build out these kind of side chains with the explicit goal of bridging them to mainnet, and we hope many others will take up that goal in the coming months and years. There are rollups, which we'll talk a little bit more around later in terms of privacy. They give you this kind of off-chain computation, and similarly with baseline, you can kind of keep the parts that you want off the chain and sort of only have the sort of absolutely necessary pieces on chain without kind of revealing your information. And then obviously at the maybe at the kind of most deeply integrated into mainnet ecosystem right now is probably ZK tokens. So such as Aztecs that live on mainnet today and give you that kind of full flexibility to interact with things on the public chain. And similarly, we have a set of technologies similar and overlapping, which allow us to achieve scalability. This other kind of key requirement, private networks, which allow you to obviously tune them however you'd like. As for example, we've seen with BSC, rollups, which allow you to kind of safely aggregate transactions for massive performance increases, and then these two other kind of performance related things which are coming past, like with the merge and past the merge, with proof of stake adding finality, which is something that really has been a kind of key requirement for enterprises and a driver for IBFT2 proof of authority, and then finally getting sharded data on the public mainnet, which allows us to kind of add this additional factor to rollups, giving them even more scalability. So there are kind of two parts to this convergence, as I kind of mentioned at the front. There is this convergence to mainnet, and there's also convergence of enterprises to mainnet. So the convergence of mainnet, and I'll apologize here, I'm very much cribbing from Ben Edgington's presentations, so hopefully he can answer anything or correct anything getting wrong here, but just talking a little bit around the merge. So ETH2 is dead. We are now talking about the merge. And first and foremost, this means the kind of combination of the execution layer, which is the current ETH1, and the consensus layer, which is the beacon chain. The pattern here is not actually very far at all from our existing kind of pluggable consensus as we think about it for building private networks. Proof of stake is a new consensus mechanism which can be combined with the existing Ethereum 1 clients executing the EVM, and this is kind of part of Ethereum's path to massive scalability. You can see the kind of merge, and then past that you can see sharding, and sort of throughout this period, and we have rollups sort of as the kind of scalability layer, and there's a little illustration I think on the next slide, which gives us a little bit more under the hood to show you how the kind of different capabilities stack together, and the delivery of this merge is very much on track and in progress, and we're hoping that that arrives sometime in early 2022. And this is one way of making it more tangible, hopefully, for people in the audience, which is that we have this kind of ETH1 engine in Hyperledger Besu, for example. We have the kind of beacon chain client, validator client in Teku, and we can kind of create this combination which sort of executes the new paradigm post-merge. And on top of that, we have our rollup solution, Sumo, which Julien will talk about more in a second if he's able. All right, well. All right,
Yeah.
Julien.
Yeah, thanks. Okay, so we are currently building a protocol Sumo, which is a layer 2 scalability solution that will solve scalability but also privacy issues for enterprises. We are currently focused on delivering Sumo for a few clients, working first on the ConsenSys rollup and targeting ZK rollup in the midterm. So a quick recap on the different kind of validation mechanism. So the rollup is going to aggregate all the transaction off chain, and then we'll submit some data on chain to validate them and mark them as validated. So the ConsenSys rollup is very similar to the way a proof of authority would work. So basically, you put all the data of the transaction on chain, and then you have you share this data. So the data can be received by other operators of the rollup, and each of the operators validates the data. So the finality is in seconds. You just need to wait for the operators to validate the batch of transactions. It doesn't require your knowledge proof, and the bottleneck is really based on the amount of data, the data availability that you can put on the chain, and the execution of each operator. And the security relies on the fact that you have enough honest operators, so really a POA based rollup. Then you have two other types of rollup, optimistic rollups, which are probably the most advanced for mainnet use cases currently. They used so the way they work is you put the data on the chain and you consider. I mean, there is some people can come with a fraud proof of the execution to show that the user misbehaved, and this proof can be brought 1 or 2 weeks after the initial validation of the block. So this is why the finality is much longer. The bottleneck is based both on the block size because of the data availability, but also based on the zero knowledge proof because there is a challenge. The challenge is done by zero knowledge proof. The security relies on the fact that there is at least one honest operator that will bring a zero knowledge proof of the fraud. And yeah, so this is probably the most advanced rollup currently. And there is a few competitors that are working toward the optimistic rollup. And finally, zero knowledge proof rollup, ZK rollups. Here you prove the validation of the transactions by bringing directly a zero knowledge proof at every step. So either at every step or regularly every minutes or every hours. The bottleneck is really based on the zero knowledge proof itself, and the speed at which they can be generated and validated on the chain. And here as you prove every time that the proof is correct, there is no way to cheat the mechanism. On the two ZKP ones, and especially on the ZK rollup, there is a lot of research going on. There is a lot of optimization going on, and we expect that we will the throughput will increase after months and years of research continuously. Jay, do you want to continue?
Awesome. Thank you very much, Julien. So talk a little bit about how mainnet is converging in the future, and we're bringing these kind of different parts together. Now I'm going to be talking a little bit around how this kind of enterprise ecosystem of private networks converges. So you can see, as I mentioned before, Quorum is kind of a natural side chain, and we're already hearing from many users about how bridge the gap between private networks and to connect them with the public mainnet too. So we have a lot of these private networks out there. These are just some of the options that they have for bridging them, and some of the ones that we're working on within the protocols group. So we have these kind of the kind of general purpose bridges like orchestrate bridge, chain bridge, or POA bridge, and these kind of allow for kind of generalized asset transfer, but have kind of a trade-off in terms of and sort of smart contracts, but have a trade-off in terms of the kind of security properties. And then we also have HTLCs, which allow you to atomically exchange assets between different networks. And this is one example that's going to be baked into Sumo in terms of providing an on and off ramp between the network it's deployed to and the rollup, as well as allowing for exchanges between different L2s. And then finally, we have GPact, which is a protocol designed by Protocols R&D, which allows for atomic cross-chain composable smart contracts, for which there's a proof of concept in progress, and there's extensive research been done by Peter Robinson and his team. And so this is the kind of almost where we are today. You can do these things today. You can sort of bridge between private chains and between the mainnet. And we think the next phase is that's coming, and we're seeing this develop, is sort of adding rollups to mix. So you will be able to deploy these rollups to private networks, and in particular, this is what our CBDC solution looks like, and it is the way that we will be powering up Codify modules in the near term, and it's kind of the natural next step for private networks, and it doesn't sort of break any of these cross-chain properties. So we expect that while there'll be continued kind of private chains not using rollups for sort of the medium and long term, many enterprises will start to choose to use rollups on their depending on their use case, to sort of tap into that scalability and privacy characteristics. And then sort of going one stage further, we have these rollups on the public mainnet, and sort of creating these bridges between them is something that's going to be possible. But we also foresee that many enterprises in the future will actually choose a mainnet rollup based architecture over private networks, as in many circumstances and configurations, they can provide similar granular control, but without necessarily the same overheads as a full private network. Again, using these various these cross-chain solutions for bridging these networks. And that kind of brings us to what the product stack for protocols looks like to support that. So you can see Sumo kind of there in the middle, adding this massive scalability for applications on top of Quorum networks. And then at the top, these interledger solutions that we're working on, enabling the connectivity between applications on different networks and different architectures. And what that brings us to is, let me skip ahead, is this kind of final view of this kind of ecosystem of different types of networks and architectures all plugging together. And there's a very rough timeline at the bottom. Please don't hold us to it. That is indicative. But you can see that we can have this expectation that we are moving from a world in which you have lots of siloed networks and sort of bridging together to make this kind of interconnected global network, which all kind of anchors to the Ethereum mainnet. And hopefully this is useful. And you can see there are different logos scattered around there. So obviously Quorum, ConsenSys Quorum, running in both its mainnet and private network flavors. And you can see Sumo there for the rollups as well. And hopefully at some point in the near future, we'll have some nice logos for these different types of bridges that we're working on to add into that mix. And yes, so sort of giving some more detail to those bridges, we have various different types of asset bridges available today. We're adding the HTLC capabilities to our rollups, and we're hoping to sort of add GPact into that mix later in the future. And so here is another nice view of what that looks like in terms of our rough roadmap. This is the stuff that sort of brings us towards convergence. There's lots of other stuff as well, obviously, and hopefully we'll be able to continue fleshing this out as we move forward, and particularly as we get these kind of new enterprise projects, which allow us to kind of add more detail to this roadmap and sort of add more features and and be more certain where we're going and where enterprises want to go. All right, that is the end of the presentation.
So Vijay, we actually have one question from Peter. For optimistic rollup, I thought they were EVM compatible. How is SNARK used to prove incorrect behavior given the EVM?
I think that's one for Julien, if he's still around.
Yes, so that's correct that the optimistic rollups are EVM compatible. Mostly EVM compatible. There is some EVM instructions that are not compatible, but that's a very, very few set of instructions. They are mostly compatible. And for ZKP, it's much more complicated because you cannot prove the EVM inside a zero knowledge proof. It's much more complicated. So the way the challenge is performed, I think it depends on the implementation. For Arbitrum and for Arbitrum, for example, it's different. They are doing it in a different way. I will not be able to describe exactly how they are doing the fraud proof. That's something that you should probably ask to the R&D team directly, or maybe I don't know if someone, maybe Ben would be able to answer. I don't know.
Ben, would you like to join the screen and talk this a little bit?
I'm not sure. I'm just.
Okay, so Ben is up to it and he's joining now.
Cool.
You hear me?
Yes. Hey, Ben.
Splendid. Yeah, so I think the question is about how fraud proofs are constructed in optimistic rollups. It's news to me if they use zero knowledge proofs. I don't think it's required. So I think that probably answers the question.
Peter, thoughts? Was your question? Okay. Any other questions from the audience? Okay. Vijay, Julian, anything else you want to add?
Oops. This was just my final slide, which was supposed to be reminding people that they should reach out to our product managers if they want to follow up for questions. Apologies for anyone who didn't know that they were going to feature on this slide, but we have kind of experts on Teku Bezu, the merge, ETH1, the former ETH2 rollups here in the middle, and then the kind of ETH1 layer for enterprises. Reach out to myself. And there are definitely better deep dives into several of these topics if you really want to go into them in the R&D week notes and recordings, which you can find the link to there. Definitely recommend that.
Yeah, and the deck will be shared as part of the Confluence page, so you can find both the recording of this workshop as well as the deck and the links to R&D week in the Confluence page. So thank you, Vijay. Thank you, Julian. Thanks, Ben, for joining as well, kind of like last minute to answer a question. And thank you, everyone, for attending. I think I learned a lot, and I'm sure everyone else has as well. And have a lovely Friday.
Thanks, Vijay. Thanks, Julian. Great job.